That is the second method to calculate the pH of 10 to raise minus 8 molar aqueous solution of hydrochloric acid. In last video we have already calculated the pH of this concentration of HCl. That was the first method. That is the second method, and we know that HCl is the strong acid and is fully dissociated in the hydronium ion and chloride ion. Ka of this acid 10 to 1.3 10 to raise minus plus 6, that's very greater than 1. If value of Ka, that is the ionization constant of acid, if greater than 1, it shows that your acid is very strong even at very low concentration. And concentration of HCl, that is 10 to raise minus 8 molar. If we calculate the pH of this 10 to raise minus 8 molar, the pH would be equal to 8. That is the basic. How it is possible HCl show pH greater than 8? It's mean there is some flaw. To fulfill this flaw, we contribute the water auto ionization. We know that if water involved in auto ionization, show the equilibrium constant value, that is the ionic product of water 10 to raise minus 14 at 25 Celsius. It cannot be neglected. Okay, to solve accurately, you use charge balance and water dissociation equilibrium. We know that chloride ions only come from HCl. That is the only one source, and HCl is completely dissociated. It means concentration of chloride would be equal to the concentration of HCl. Okay, number one. Number two, positive ions and negative ions should be equal. It means hydronium ion, that is the positive ion, should be equal to the hydroxyl ion plus chloride ions. Okay, we take the hydroxyl ion as a X, that is the unknown concentration. Okay, because reason is that hydroxyl's source of hydroxyl ion only water, and water is very weak base to give hydroxyl ion. Okay, so we consider this concentration is equal to X. If we put the value of X in the above equation, new equation should be hydronium ion is equal to X plus 10 to raise minus 8. Okay, and we also know that at equilibrium position water dissociate into hydronium ion and hydroxyl ions. Okay, W is equal to the concentration of hydronium ion multiplied by the hydroxyl ion, that is equal to 10 to raise minus 14. If we put this value of hydronium ion, that is equal to 10 to raise X plus 10 to raise minus 8 in this equation Kw, that would be the equation X plus 10 to raise minus 8, and hydroxyl ion also is equal to X is equal to 10 to raise minus 14. If we rearrange this equation and we multiply this X, new equation would be X square plus 10 to raise minus 8x minus 10 to raise minus 14 is equal to 0. It means that part is equal to A x square, that part is equal to bx, that part is equal to C, which is standard form for the quadratic formula. It's mean A is equal to 1, B is equal to 10 to the raise minus 8, C is equal to 10 to the raise minus 14. If we put these values in quadratic equation, we find out the value of X, that is 9.5 10 to the raise minus 8 molar. Okay, we know that in previous equation, we know that hydronium ion is equal to X plus 10 to the raise minus 8, and value of X from the quadratic equation we put at the place of X, and we find out new value, that is 1.05 10 to the raise minus 7 molar. That is the concentration of hydronium ion of HCl. If we calculate pH is 6.98 after calculating the log values. That is justified, that is less than 7. It's mean pH of 10 to raise minus 8 molar solution of HCl is 6.98. It is due to the contribution of autoionization of water. Hope so you understand both methods, how we can calculate the pH of HCl.